Okay, here we go. We're going to start differentiating. So we said it's the the quotient rule because we cannot clean it up. So I like abusing parentheses, and I'm just going to copy my problem out and denote what I'm going to be doing here. I haven't done any calculus, any differentiating yet. Okay, so what I'm saying is I'm differentiating the first times the second minus the second, or the bottom, times the front first. All right, so the derivative of 3x is going to be 3. And then times x squared plus 1 minus the derivative of x squared plus 1 is 2x. All over x squared plus 1 squared. Okay. Then we clean that up a little bit. We get 3x squared plus 3 minus 6x squared. Let me make my pen a little bit thinner. All right, so now the 3x squared and the minus 6x squared gives me minus 3x squared plus 3 over x squared plus 1 squared. I'm seeing something interesting here, maybe. So I pull out a negative 3. That doesn't work. Yeah. Whoops. Okay, so that's really all you can do with it. All right, let's talk about it. Even if I pull out another negative out of the top, it would be, negative x squared plus 1. It still doesn't get me anything closer. X squared minus 1 does factor, x plus 1, x minus 1, but that doesn't help me, okay? And then x squared plus 1, it just does not factor. We do not have a rule for the sum of two squares. All right, so guys, you could have stopped back here. I just kind of went forward a little bit just to kind of see. All right. So that is number 1. Number 2 is 0. Don't get confused with that. Pi is nothing more than a constant. All right. So that is 0. 1 plus cosine over 1 minus cosine. Again, can't clean it up. Can't really do much. So we're going to do the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. All right, the derivative of 1 plus cosine is going to be negative sine. Okay, and the derivative of 1 minus cosine is going to be negative sine, so that's going to be a positive sign. So I'm just going to pull it out front. One minus cosine of x squared. All right, let's see what we can do here. So I do have a sine of x that's common. So I'm going to pull out a sine of x. And let's see what's left. Here I'm left with 1 minus cosine of x. All right. And then minus 1 minus cosine. All right. Let me get rid of these parentheses so we can kind of start grouping here. All I did is I took this negative and I distributed it through to here and to here. That's where that negative 1 came from, was that negative out here. This sign I pulled out front. Okay, so again, sine times 1. Again, if I would have factored that sign through, then I could have showed that, but I just kind of skipped that step. All right, everyone all right? Yeah.
The negative from the first side, not the one that distributed to the 1 plus cosine.
It's right there. All right, so that changes everything. I didn't see that guy right there. So actually, no. Let's see what I can do here. If I pull out a negative sign, yep, I didn't see that front sign. Let's fix this. Sorry about that, guys. All right, so then this would be a negative sign out front, and if I do that, it'll change this to a positive right here. Okay, so I'm left with 1 minus cosine of x, and then just simply plus 1 plus cosine of x. Let's see if that's legit. So if I pull that out, I'm left with plus, that's gone, that's gone. Yeah. All right. X squared plus 1, quantity squared. So 1 plus 1 is 2. What's that? I'm looking right up above. Sorry. I should have left more gap here. All right, so the cosines are gone up here. Minus cosine plus cosine. So I have a 2 here. So I get basically minus 2 sine of x all over 1 minus cosine x squared. All right. And if I was to FOIL the bottom out, I'd get a mess. Let's see if that actually helps me out. 1 minus 2 cosine of x plus cosine squared of x. Not really. Okay, so sometimes you remember those trig identity, sine squared plus cosine squared equals 1. Therefore, 1 minus sine squared equals cosine squared. Problem is I don't have a sine squared in the top here, so it doesn't really help me. All right, so there we go. That's number 3. Number 4. Perfect. All right, number 5. We've got the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. All right, here we go. We got 2 times 1 minus 3x squared minus 2x times negative 6x. All right, I'm just going to clean this up first before I copy the bottom down here. So I'm going to kind of just FOIL or factor through things here. I got 2 minus 6x squared minus plus 12x squared. All right, 12x squared minus 6x squared gives me 6x squared plus 2. I could pull a 2 out. That leaves me with 3x squared plus 1 all over 1 minus 3x squared squared. All right, not quite done, but I just kind of want to point that out here. Yeah. From here to here? Oh, so 2 times 1 is 2, and then 2 times negative 3x squared is negative 6x squared. And then I just put that through. All right, these are kind of reversed. I see a positive 1 and a positive 3x squared, but it doesn't work. They have to be total opposite signs for you to pull out a negative and all. So, again, if you mess up a negative, it can go south. So that is our answer. All right, we've got product rule here. So x squared through the first times the second plus the derivative of the second times first. All right, here we go. We got 2x tan of x. And what's the derivative of tan? Secant squared. Okay, so x squared secant squared of x. Done. Yeah, you can pull out an x. Doesn't get me anything closer to anything. Doesn't help me out. Yeah. We could go nuts with this converting, but again, it doesn't help me. All right, number 7. What's derivative of 3 is? Wrong. 0. Okay? E is a number. A number raised to a number is a number. The derivative of a number is 0. Okay? So be careful. Our rule is e to the x. See how there's a variable in the exponent? So in this case, this is a constant. Okay? So this is 0. All right, here we go. Let's keep going. Maybe I'll get this whole thing done. All right, we got simple product rule here. Now, it'd be nice if it was just an x underneath the radical. Then I can just combine and do a normal power rule. But I can't. All right, and so I'm going to do derivative of the first. And I'm going to rewrite this as like that. Plus the derivative of the second. All right. Now, this one kind of slipped in. I kind of did this subconsciously, this problem. Technically, you don't know how to do this problem yet. We only know how to do like square root of x. We do not know how to do square root of x plus 1. But I will tell you it's going to turn into the same thing. Okay? It really matters when the function inside the radical gets wacko. And that's chain rule, by the way. Okay? But for this one, it doesn't matter. All right? So we're going to go ahead and just pretend we know how to do it. All right? Derivative of x cubed is 3x squared. And I'll just leave my radical, x plus 1. And the derivative of this is going to be 1/2 x plus 1 to the negative 1/2. And then I still have an x cubed here. Okay, cleaning that up, we get 3x squared times the square root of x plus 1. This all becomes x cubed over 2 times the square root of x plus 1. I could simplify it if I wanted to and get it to be one big giant fraction. But again, it doesn't help me out. It doesn't get me anywhere closer than I need to be. All right, again, the 2's in the bottom. This negative exponent shoves all this in the bottom, and the x cubed is just staying in the top. All right, here we go. Product rule. Derivative of the first times second, and derivative of second times first. So derivative sign is, and what's the derivative of cosine? Negative sign. Put it up there for now. So the front part is cosine squared, and the back end is minus sine squared. Okay. Almost our rule, sine squared plus cosine squared, but it's not. So we just leave it alone. If it was a plus, that whole thing would go to 1. Everyone okay? Does everyone feel like they're getting a good grasp of this? Differentiating? Good. Good. All right, derivative 4x. All right, now that's not attached or associated with the quotient, so I'm just going to do it right off the bat and get it done. That's 8x. Now I've got to do this one. Now, can I rewrite this? I don't want to use quotient rule. I can. This is going to be kind of looked at as 2 times 1 over sine. And 1 over sine is cosecant. Okay? All right, so this really becomes minus 2 times cosecant of x. So we haven't differentiated yet, but all I did was rewrite this. This is just the rewrite. Now let's just do our thing. What's the root of cosecant? Negative cosecant cotangent. Okay? So this becomes, and the constant multiple rule says ignore the constant, do the derivative, and then just tack on your constant. So we get negative 2, but cosecant is negative cosecant cotangent, so that becomes a positive. All right? Actually, for note purposes, I'm just going to let it stay like this. That way you can look back. Negative negative becomes a positive, so it's 2 cosecant of x, cotangent of x. And I still have the 8x out front. That's my answer. Okay, so all I did is rewrite this to this guy right here. And then it was easy to go to here. But again, this is just a rewrite. Now it's easy to differentiate. All right, if I have this, again, I would FOIL this together first. Okay, so we're going to get x cubed minus 2x plus x squared minus 2. All right, and let's just differentiate it right down the line now. We get 3x squared. I'm going to do the x squared next, plus 2x, just to do descending powers, and then minus 2. And then minus 2, the derivative of that is 0, so there's my derivative. A lot easier than product rule. Because you notice the product rule, you're differentiating twice. You have to do the derivative first, got a mess. Plus, derivative second, got a mess. All right, 12 is more of a definition. Derivative of x is 1 minus, and what's the derivative of cosecant? Negative cosecant, cotangent. Okay, we clean that up. 1 plus cosecant. Really? $13, we do have to use product because I can't combine that e to the x with anything. So I will do 3x to the 4th, prime it, 5 e to the x plus 3x to the 4th times 5 e to the x. And I'm going to differentiate that. All right, here we go. We got 3x to the 4th, which is 12x cubed times 5 to the ex plus 3x to the 4th. And the derivative of 5e to the x is 5e to the x. Okay, we ignore the constant, differentiate e to the x, and then tack our constant back on. All right, let's see if we can clean this up a little bit. This is all just one giant product here. So what's 12 times 5? So we get 60x cubed e to the x. And this is all one big giant product, so it's going to be 15 x to the 4th e to the x. Okay, now, yeah, I could pull out an e. Yay. I could probably pull out a 15 as well. Does that look any prettier than this? Not much. What's that? Oh, yeah, I can pull out another x cubed, right. Sorry. But, yeah, so there's a common x cubed here. Thank you. 5, 15x cubed e to the x. 4 plus x. Okay, great. Doesn't get me anywhere nicer. It's not going to help my life in any way. It doesn't make me a better person. All right. Next one. We do this in our sleep now, right? 15 x squared minus 2. Done. Okay. This one, I do have to split up. So the derivative of the first times the second plus the second times the first. All right, this becomes 1/2 x to the negative 1/2 sine of x. And my laptop's like burning on fire. See, I'm recording the screen and displaying wirelessly and writing, so it's like on fire. It literally is not like that. Alright, and the root sine is cosine of x. Alright, let's see if we can clean it up just a little bit. Alright, so this goes to the bottom, so we're going to have sine of x all over 2 square roots of x plus square root of x cosine of x. I just don't like negative exponents. Yeah, right, it doesn't help me, but... Alright, we were able to rock this whole thing out. Dead tired from last night. We really got this. Alright, this is nothing more than x to the innie over outie. Alright, 2/3. X to subtract 1. Remember our trick. 2 minus 3 over 3. So, negative 1/3. Cleaning it up, we get 2 over 3 cube root of x. Alrighty? Easy peasy. Alright, any questions? Alright, I'm going to kill the recording here.